Hello everyone. In recent videos we have already discussed about the concept of dispersion and some of its measures like range, interquartile range and quartile deviation. In this video we will talk about other measure of dispersion, that is variance and standard deviation. Variance is a measure of variation that accounts for how all the values are distributed in a data set. It conveys how widely or tightly, these two words are important, how widely or tightly the observations are distributed from the center. So these three words are very important: widely or tightly the observations are distributed from center, that means from mean value. So we can say that it's an average variation of data points around central value. Variance or standard deviation is widely reported along with mean. Okay, why along with mean? Because it's the average variation of data points around mean. That is why we should use variance or standard deviation along with mean. Now let's try to understand the concept of variance and standard deviation with the help of diagram. So this is the frequency distribution, where on x-axis we have data points, in y-axis we have frequency of occurrence of each data point. Okay, so variance tells us the average variation of data points from mean. So from this point to other points, variation, average variation around mean. Okay. Let us take one example to understand the concept and formula of variance and standard deviation. Suppose we have weight of 5 subjects as 1, 2, 3, 4 and 5 kgs, and we wanted to know about variability in this data set with the help of variance or standard deviation. That means first of all we need to calculate mean of this data set. Right, you might think at this point of time, what is the need of calculating mean for computing variance? Okay, so because variance or standard deviation is the average variation of data points around central value, average variation of data points around central value means around mean. That is why first of all we need to compute mean of this data. So let's take mean of this data very quickly. Sum of all observations in this case will be 15 and total number of observations are 5. So mean will be 15 divided by 5, that is 3. 3 will be the mean for this data. Now take deviation of all data points from 3 kgs value of mean. Okay, so that means what we need to do is we need to calculate the difference of each data point with its mean value of 3. That means 1 minus 3, 1 minus 2, 1 minus 3, 2 minus 3, 3 minus 3, 4 minus 3 and 5 minus 3. So this will be minus 2, minus 1, 0, plus 1 and plus 2. Okay, now because for calculating average we have to sum all observations, so now to calculate the average of variation of data points around central value we need to take average of these values, right? But if we try to calculate sum of these observations, these differences, let us say this is D, difference or deviation. Okay, so minus 2 will cancel off with plus 2 and minus 1 will cancel off with plus 1. Okay, so the resultant sum will be 0. Okay, and because of this the average variation will be, because of this average variation will be 0. Okay. So guys, please remember this point. Whenever we are adding up deviations of data points from its mean value, it will always be 0. This is the property or characteristic of mean. Okay. So now the next question is, what is this mean value of deviation indicates in this example? Okay. So in general, 0 indicates absence of a particular characteristic, right? And we already talked about it during discussion on data types. So here, what is this 0 indicates? The 0 value of average deviation indicates absence of variation. But we know that there is some variation in our data, as all the points are not same. Here the points are not same. This is 1, 2, 3, 4, 5. Okay. If it was suppose the data was like 1, 1, 1, 1, 1 or 2, 2, 2, 2, 2, that means if every data point will remain same, only that time variance or standard deviation can be 0. But here this is not the case. We have different data points in our data. Okay. If we are looking at the difference or deviations of data point from its mean value, okay, so mean is 3, we can see that the difference between 2 and 3 is 1. Similarly, difference between 3 and 4 is 1. And the difference between 1 and 2, just 1 minute, let me just choose a pen of another color. Yes, the difference between 1 and 3 is 2. And difference between 3 and 5 is 2. Okay. So if we take average of these differences, what is this? These are the differences from mean. Okay. So if we take average of these differences, so the numerator will be 2 plus 1, 3, 3 plus 1, 4, 4 plus 2, 6, divided by, there are total 4 observations, right? So it will be 1.5. So if we ignore the sign of deviation, then average variation of data points around its mean is 1.5 kgs, right? Now let's do this with the help of formula for variance and standard deviation. Okay, so just to overcome the problem here, if we are simply taking the average of variation of data points around mean, we get the value of 0, and this is not the true representative of the dispersion in my data. Okay, so we need to look at some other solution. Okay, so if we simply square this quantity, if we simply square this d, okay, so this will be d square. That means it's a square of data point minus mean weight. Okay, so in this case, minus 2 square become 4, minus 1 square become 1, 0 square will be 0 only, plus 1 square is 1 and 2 square is 4. This time this sum is 10, right? And now we take average of d square. Instead of taking average of d, if we take average of d square, then it will be 10 by 5, that means 2. Okay, so what this 2 indicates here is, that means variance of this data is 2. But remember one more point, that the moment we took square of deviations, its unit also get squared. That means unit of weight was kg. See, unit of weight was kg. Unit of the difference between the data point and its mean value is also kg. But when we square the values, its unit will also get square. So here the unit will be kg square. So that means this is 10 kg square divided by 5. So variance is 2 kg square. Okay. Now it becomes a little bit difficult to understand variation of 2 kg square. So what we can do is we can simply take square root of 2 kg square. So if we take square root of variance, this 2 kg square is variance. Okay, so if we take square root of variance, then we call it as standard deviation. Okay, so simply here standard deviation will be square root of 2 kg square. Square root of 2 will be 1.414 and square root of kg square will become kg. So we are again coming back to our original unit of measurement. Now it is easy to understand that the mean of this data is 3 kg and variation which we measured by using standard deviation around mean is 1.4 kg. Okay. In fact, in most of the research papers, you might have seen that 3 plus minus 1.4, something like that. Okay, so that means we are talking about mean plus minus standard deviation. Okay, mean represents measure of central tendency and standard deviation represents measure of dispersion around mean value. Okay. This becomes the rationale to choose standard deviation as measure of dispersion when we wanted to report mean as measure of central tendency. Here we have formula to calculate variance and standard deviation. Okay, the first one is variance. It is indicated by sigma square, and the next one is standard deviation. This is denoted by sigma. Okay, the formula is same. Data point, xi denotes data point and x bar denotes mean, and small n denotes sum of all total number of observations, and this sign denotes summation. Now we will learn how to compute variance and standard deviation using Microsoft Excel. To calculate variance, we have to use var function. Okay, so just tab it, select the data, close the bracket and enter, and we can compute standard deviation by using the formula STDV, this one. Okay, so in this data where we have age of 20 participants, the variance of the data is 1.25 year square and standard deviation of 1.1 years. Okay, so this your question into comment section. You can also mail me your questions. I would love to answer all your questions. Keep watching, keep learning. See you next week. Thank you.